Now we are going to discuss the case area under curve when the curve is symmetric about axis. So the first case is when curve is symmetric about x-axis. Consider the case if the curve and the region bounded by the curve are symmetric about x-axis, and if one part of the area is in upper semi-plane of x-axis and second part is in lower semi-plane of x-axis, then the total area of the region will be 2 times the area in the upper semi-plane. That is, if we consider this is the x-axis, this is y-axis. As we said earlier, one part is upper plane of x-axis and other part is in the lower plane of x-axis, and this is x is equal to a and this is 0, then area is equal to 2 times 0 to a f of x dx. That is, curve is symmetric about x-axis. Similarly, in case of curve symmetric about y-axis, then area A is given by A is equal to 2 times 0 to a t of y dy, where we have this is x-axis and this is y-axis, and curve is just like that. That is origin, and this is y is equal to a. So the area is 2 times range varying from 0 to a gy dy. These are the two cases when the curve is symmetric about x-axis and symmetric about y-axis. So we can find out the area 2 times of this. Now the case is when the curve is symmetric about both the axes. We will find out the area when the curve is symmetric about both the axes. If the curve and the region bounded by the curve are symmetric, about both the axes, then its area can be calculated by considering the area of region in the first quadrant and multiplying the same by 4. That is 4 times the area lying in the first quadrant is the area of the curve of given region. For example, region bounded by a circle ellipse are the examples of this type. Consider a circle. This is the x-axis and this is the y-axis. So this is a circle. So it is symmetric about the x-axis. If we see, these both curves are symmetric. This is a symmetric, and if we take about y, so it is symmetric in this shape and in this shape. So it is symmetric about x-axis and y-axis. We have to find the area of whole region. So area of whole region is area is equal to 4 times area lying between first quadrant, that is this area. So we have to find this area as this is 0 and this is a comma 0 and this is minus a comma 0. So it is 4 times 0 to a f of x dx. Now we consider the case of ellipse. If we have ellipse, that is x-axis and this is y-axis. If this is ellipse, you can see that it is also symmetric. This is called major axis of length 2a with coordinate a0 and minus a0, and this is called minor axis with coordinate 0 minus b and 0 comma b. So area of this whole region is 4 times the area, that is varying from 4 times 0 to a f of x dx, or we can also find in both cases 0 to b g of y dy. It is depend upon our choice. We are taking the limit from ranging from x-axis, that is from 0 to a or 0 to b. So we have to consider the curve on the basis of this. So it was all about the cases, area under curve between the two curves, between the axis and the given curve, and between or the symmetric curve. So we'll do some problem to understand these articles.